Hi, welcome to Harris Maths. Anne sells her large art for €13 and her small art for €12. Yesterday she sold 9 art pieces for a total of €113. How many large pieces did she sell and how many small pieces of art did she sell? Well, let's try and represent this using unknowns. We have X representing large and Y representing small art pieces. Now she's sold a total of €113, so she sold 13 large ones, 13 times X, and 12 times Y small pieces, and that's equal to 113. It also says here that she sold 9 art pieces, and we know she has large and small, so 9, which comprises X as large and Y pieces, that gives us 9. So now we have two equations, and these are simultaneous equations, so we'll solve these two. We'll try and eliminate Y, it looks easier to eliminate. We'll multiply equation 2 by -12. Equation 1 stays the same. Equation 2 becomes minus 12x minus 12y is equal to minus 108. Now we add these two and eliminate y, so y goes out and this becomes x is equal to 5. If x is equal to 5, then x add, or 5 add y is equal to 9 implies that y is equal to 4. So she sold 5 large pieces and 4 small pieces. Well, let's see if we can check that. From this first equation, 13 times 5 add 12 times 4, that gives us 65 add 48, which is 113. So this proves that our answer, she sold 5 large pieces of art and 4 small pieces of art. Thanks for watching. My name is Alistair. Don't forget to like, comment, subscribe and turn on notifications. Bye for now. How to determine whether simultaneous equations have a solution. Suppose we have two simultaneous equations and they're written in the form y is equal to ax add b and y is equal to cx add d. And we'd like to find out whether they have solutions, and if they do have solutions, how many solutions do they have? Well, first we could look at the two constants a and c. If a is not equal to c, then the lines, bear in mind these are two straight lines, these represent the generalized straight lines, and if you plot them on a graph you'll have two straight lines, and those are the two lines I'm actually referring to. The lines representing the equations are not parallel, meaning that they cross at some point. So these two equations with A and C not equal to each other will have one solution. So it's based on this condition that A is not equal to C. If the constants A is equal to C, then we have a different situation. The lines representing the equations are parallel. And what that means is that they do not cross at any point. And hence, the equations have no solutions. So, no solutions. Parallel lines, no solutions. But there is an exception to the rule. If B and D, so these two constants, if B is equal to D, then the two equations are the same. And they have infinitely many solutions. And that's it. Any questions, comments are all welcome. My name is Alistair. Don't forget to like, follow, or subscribe for other videos like this. Thanks, and bye for now. Hi there. We need to solve these simultaneous equations. We'll call this equation 1 and this equation 2. We'll try and rearrange equation 2 because there's nothing we can actually do here with x times y is equal to 270. If we divide both sides by y, we won't make any progress, nor if we divide both sides by x. So if we look at equation 2, we can rewrite it as the log of x divided by y squared. So this would have been log y squared, and that power now becomes a factor. The negative sign between this log and this log allows us to write it as a division. That's rule 2 of logarithms. If you look at my previous videos, I explain and give an example of the use of rule 2. Now this implies that x, oh, I forgot one thing, is equal to 1. So this implies that x over y squared must be equal to 10. Because if we take the log of 10, it's equal to 1. Or we can write this as x is equal to 10y squared. And now we can make a substitution into equation 1 because now we know x, or we could have used y, just that x is easier to use. So if we substitute x equal to 10y squared in 1, What do we get? We got 10y squared times y is equal to 270, which means that 10y cubed equal to 270, so y cubed so implies that y cubed is equal to 27. Which means that y is equal to 3. And if y is equal to 3, we can find x, because x times 3 is equal to 270, which means that x must be equal to 90. So our solutions are y is equal to 3 and x is equal to 90. Thanks for watching. I'm Alistair. Bye for now. Hi. We have two simultaneous equations, or a pair of simultaneous equations. We'll call this equation 1 and this one equation 2. We'll use the substitution method to solve these. So why don't we just use this equation 2 and rearrange it, so we have that 2n is equal to 19 minus 3m, which gives us that n is equal to 19 divided by 2 minus 3 over 2m. So now that we know what n is in terms of an expression, we can substitute, and we'll do that. We'll substitute in equation 1, and that will give us 2m minus 3 of this whole quantity here, which is 19 over 2 minus 3 over 2m. And this is equal to negative 9. This will give us 2m minus 57 over 2 minus 9 over 2. In fact, add 9 over 2. That's equal to negative 9. And this simplifies to give us 13m is equal to 39, and m is equal to 3. How do we know if we're correct? Well, we'll come to that. First we have to find n, and we'll substitute in equation 1. So we have 2 times m, which is 3, minus 3 times 3n is equal to negative 9, and that gives us minus 3n equal to negative 15, so we know n is equal to 5. And to check to see whether our solutions m equal to 3 and n equal to 5, we can substitute in equation 2 3 times m, which is 3, add 2 times n, which is 5, that gives us 19, which indicates that our solution of m equal to 3, n equal to 5 is correct. Thanks for watching. I'm Alistair. Bye for now. Today we'll talk about solving simultaneous equations using the substitution method. And first I can see that I have y on its own here, so this is a good candidate for me to rearrange. So I'll rearrange equation 2, and that now becomes y is equal to 13 minus 3x. And now I'll substitute into equation 1. So we have 3x, add 5 of this, which is 13 minus 3x, and that's equal to 29. And with a bit of algebra, I have 65 minus 15x is equal to 29. If I rearrange this, I take the 29 and bring it over to the left, and I take the negative 15x becomes 15x on the other side with minus 3x, which gives me 12x, and that's equal to 36. So we know x is equal to 3. And if we know that x is equal to 3, we can easily substitute in this equation, equation 2, to find y. We know x is 3, that's 3 3's 9, add y is equal to 13, so y is equal to 4. Here's our next pair of simultaneous equations. We could arrange here to find for either x or y. We'll do it for y. So if we divide by 4 on both sides, we have minus x is equal to y. So that's equation 1. We have something in terms of y. We can swap the sides and write that y is equal to minus x. And now we can substitute into equation 2. So we have 4x minus 8 minus x, and that's equal to 12. And this gives us 4x add 8x is equal to 12. So we have 12x is equal to 12, so x must be equal to 1. And if x is equal to 1, if we substitute in this equation, then we have y must be equal to minus 1. We could also use this equation. If x is 1, then y is minus x. So y is equal to minus 1. And here's our last pair of simultaneous equations. This one seems obvious. We have something in terms of x, and then in equation 2 we have 3x minus y is equal to 17. So we can just substitute for x in equation 2. So we have 3 of y add 7 minus y is equal to 17. So that gives us 3y add 21 minus y is equal to 17. So we have 2y on this side, and it's equal to 17 take away 21, which is negative 4. So y is equal to negative 2. If y is equal to negative 2, then we have negative 2 add 7 in equation 1. We have that x must be equal to 5. And that's it. Don't forget to substitute your values, your unknowns that you found, x and y, into any one of these original equations to check your answer is correct. Thanks for watching this video. My name is Alistair. Please like, and also please follow or subscribe for more videos like this. Thanks and bye for now. Hello. Solve the simultaneous equations shown here. We have to just rearrange each one of these. So the first one was equation 1 and this is equation 2. So the first one will become 2x minus y is equal to negative 3. And the second one is 3x minus y is equal to 2. We want to be able to eliminate one of these unknowns. So the elimination method requires us to set up one of the equations so that when we add, we eliminate one of the unknowns. We'll go for eliminating y. So we'll multiply the second equation here by negative 1. So the first one remains as it is. And the second one becomes minus 3x add y is equal to negative 2. We add these two equations, they give us minus x is equal to negative 5. It means x is equal to 5. And we can find for y by substituting in any one of these equations. We'll go for the first one because it's simpler. Y is equal to 2 times 5 add 3 which is equal to 13. So our solutions, x equal to 5 and y equal to 13. Find the point of intersection of the equations. Y is equal to x add 3 and y equals 3x minus 2. Well, these are the two equations we just found the solution, simultaneous solution, which is x equal to 5 and y equal to 13. If these are the solutions, they also imply that they're the points of intersection. We could use this as a way of checking, means that if they're equal to each other, so let's equate this equation to this equation, this one, sorry, we have this is equal to 2x add 3, and we can have here that x is that, yeah, x is equal to 5. We substitute x equal to 5 here, we have 15 minus 2, so y is equal to 13. So we could just state that the solution of the simultaneous equations also indicates the point at which these two equations intersect, or the graphs intersect. These are the equations of the graphs. Or we could just calculate it. Show that the graphs with equations y equal to 2x add 3 and y is equal to 2x minus 12 do not intersect. Well, if we equate them, 2x add 3, if we can find a solution, then the two equations intersect. Here we'll have 2x minus 2x is equal to minus 12 minus 3. This will give us 0 is equal to minus 15. So unfortunately this is not a solution. It doesn't make any sense at all. And this indicates that these two graphs do not intersect. The fact that we don't have a solution. Thanks for watching. My name is Alistair. Bye for now. Hi, How do we go about solving this by substitution, using the substitution method? Often we use the elimination methods, but let's try the substitution method. We always look for the equation where we can rearrange to find either x or y and then substitute. I'll try using x in this case, and I'll use equation 1. So we have that x is equal to 10 minus y. So we now know the value of x, and in equation 2 we can write that 3 times 10 minus y. Instead of 3x, we have 3 times 10 minus y is equal to minus y at 22. This gives us 30 minus 3y is equal to minus y at 22. Now, if we rearrange this, we have minus 2y is equal to 22 minus 30 minus 2y is equal to minus 8. So we have that y is equal to 4. And now we know that y is equal to 4. We can substitute in either equation to find what x is. So here, if y is equal to 4, then we have x add 4 is equal to 10, so x is equal to 6. Don't forget to substitute in both equations to check your solutions. Here we have an easy option to choose y as our subject of equation 2. So we can add that y is equal to 13 minus 3x. We could have used x, but it's just a bit more of a calculation. So now that we know y, we can substitute our value for y in equation 1. So we have 3x add 5 times this amount, 13 minus 3x, and this is equal to 29. So we have 3x add 65 minus 15x is equal to 29, which gives us minus 12x is equal to minus 36, where x is equal to 3. If x is equal to 3, we can substitute in equation 2. We'll have 3 times 3, and y is equal to 13, so y is equal to 4. Don't forget to check your values for both equations to confirm that your solutions are correct. Thanks for watching. I'm Alistair. Bye for now. Hi, this is Harris Maths. Suppose after or during the course of creating a mathematical model, you arrive at these two simultaneous equations. P is the equilibrium price and Q represents the quantity of apples, a certain brand of apples. And we want to solve these two simultaneous equations. So first we want to get rid of a fraction, so we'll multiply this equation by 4 and this one by 8. And what we have is 4Q is equal to P minus 200. And this is 8Q is equal to minus P add 560. In order to solve this pair of simultaneous equations, we'll just add these two equations. In that way we'll eliminate P, because when we add P to negative P we have 0. So we have 12Q is equal to 360, giving us Q equal to 30. So we know our equilibrium price is represented by P, and Q is the quantity. So the quantity that we can buy at this, or the demand, is at 30 kilograms, or some whatever units you're actually using. Now to find P, we can substitute in one of these equations. We'll try and substitute in this equation. So we have 4Q, which is 4, let's write this, 4 times 30 is equal to P minus 200. Let's rewrite that. 4 times 30 is equal to P minus 200. So we have 120 is equal to P minus 200. So we have P is equal to 320. In terms of the problem, this is the price, £3.20 per unit. So the equilibrium price is £3.20 at the quantity of 30 units. And that's it. My name is Alistair. Thanks for watching this video. If you have any questions or comments, please send them to me. Don't forget to follow, subscribe, and like this video. Bye for now.